A stone falls freely under gravity. It covers distances h1, h2, and h3 in the first 5 seconds. The next 5 seconds, see, this is the question what we were doing in a separate playlist with the title Problems Based on Ratios, right? So I think this is the last problem in that playlist. And it is essentially the same question. So let me start explaining the solution. But before that, let us try to visualize the concept. See, so what's given here is an object is dropped, and an object is dropped. So it covers. It is dropped. It's a stone falls freely under gravity. It covers distances h1, h2, and h3. Okay. So what is given is in time t1, say the body covers h1 distance. All right, and in the next t1 seconds, the body covers distance h2, and in the next t1 seconds, the body covers a distance h3. Now you may ask me, why is the distance increasing? The concept is very simple, because as the body is dropped, as it is under the influence of acceleration due to gravity, what happens is the velocity keeps on increases for equal intervals of times. If the velocity increases, then the distance traveled will correspondingly increase. It's the concept. Now, so I think it's better to name these points for better clarity. So let's say this is O, A, B, and C. Now, okay. Now let us make use of the displacement. Let us make use of the displacement time relationship, right? So we have displacement time relationship. Displacement time relationship. What is happening with the pen? Yeah, okay. Displacement time relationship. What is it equal to? S is equal to ut plus half at square. Since it is dropped from rest, u is 0. So this becomes S is equal to half at square, right? So this is the primary equation that we are going to use here. Now how are we going to apply this? See, it goes like this. The first distance traveled is h1, which will be equal to half into a here is g, and t square is t1 square. Okay, since we are given first 5 seconds, we can write h1 is equal to half into, let us take g into 5 square. So h1 is basically 5 into 5 square, right? Okay, now what is h2? See, h2 is the distance covered in the next t1 seconds. So h2 is half into. So here we need to understand one thing, which is the amount, sorry, the duration of ball or the object in the air. See, when the object had covered distance OB, right? When the object has covered distance OB, what we need to understand is the time was t1 plus the next t1, right? Or which is 2t1. And here, since t1 is 5, this is 2 into 5, which is 10 seconds. So when object was in OB, it is half into g into 10 square. So I'll write OB is equal to half into g is 5. So we can add 5 into 10 square. Similarly, what is OC? OC is the distance traveled by the object when it was in air for t1 plus t2 plus t3. Right? Sorry, t1 plus t1 plus t1 square. I repeat, OC is the distance traveled by the body when the object was in the air for T1 plus T1 plus T1 seconds. I'm sorry, I think I said T1 square earlier when I said this. So I'll correct it once again. So what is OC? OC is the distance traveled when the object was in air for T1 plus T1 plus T1, which is 3 T1 seconds, right? So what is OC? OC will be equal to half into G into, instead of T, we can write 3T1 the whole square, right? So OC further becomes, OC is equal to 5 into, what is T1? T1 is 5. So this becomes 15 square, right? Now OB is equal to 5 into T 10 square, and OC is equal to 5 into 15 square. Now what is OB? See, from the diagram, OB is H1 plus H2. So we have H1 plus H2 is equal to 5 into 10 square, which is 5 into 100, that is 500. And what is H1 from here? H1 is 5, H1 is 5 into 25, which is 125, right? So if you subtract these two equations, what do you get? H1 plus H2 minus H1 is equal to 500 minus 125 is 573, right? Yeah, 375. Which means H1 is equal to 375 and H2 is equal to 375, and what is H1? H1 is equal to 125. Okay. Now what do we have? Okay, we have OC. So OC from the figure is H1 plus H2 plus H3. So that we can write it as H1 plus H2 plus H3 is equal to 5 into 15 square is 225. Okay. So what is H1 plus H2 is equal to? H1 plus H2 from this equation is 500. So we have 500 plus H3 is equal to 5 into 225. So what is H3 is equal to? 5 into 225 minus 500, which is 5 into 100. So H3 is equal to 5 into 225 minus 100, right? So H3 is equal to 5 into 225 minus 100 is 125. What is 125? 125 is H1. So we can write that H3 is equal to 5 into H1, or otherwise H1 is equal to H3 by 5, right? So we got H1 is equal to H3 by 5. Is that option which says that? Okay, H1 is equal to H3 by 5. Similarly, we can find out H1 is equal to H2 by 3. See, what is H2 is equal to? H2 we have found out to be, what's value of H2? H2 is 375, right? H2 is 375. So I'll write H2 is equal to 125 into 3, right? What is 125? Sorry, 125 into, wait, am I making any mistake here? 75, yeah, okay. So what is 125 is equal to? 125 from the question is H1. So H2 is equal to H1 into 3, in which case what is H1 is equal to? H1 is equal to H2 by 3. And therefore H1 is equal to H2 by 3, and H1 is equal to H by 3 is the required value, which makes the correct option as option D.